Hey, what's up, everyone? Sam Charrington here, host of the This Week in Machine Learning and AI podcast, bringing you a look at my recent trip to the Consumer Electronics Show in Las Vegas. CES is one of those things that's hard to fully comprehend without having seen, so I thought it'd be fun to give you a look at it from my vantage point. In this special YouTube exclusive, we're going to check out some of the interesting examples of machine learning and AI that I found at the event. As you'd expect, there were a ton of robots on display at CES this year, but this enormous combine harvester in the John Deere booth might be one of the biggest bots you'll ever see. I spent some time speaking with Deere's Tavanga Siavora, learning about the autonomy and computer vision tech built into this bad boy. Check it out.
All right, cool. So I'm here at the John Deere booth with Tavanga, who is telling me that there is a long history of autonomy in these farm vehicles. You said you've been doing it for how long?
Certainly. So John Deere's been doing self-driving for over 15 years now. And we actually have the accuracy level with our equipment down to plus or minus 2.5 centimeters of accuracy for a piece of equipment of this size and scale. So yeah, here at CES this year, excited about telling that story and also many of the other technologies we continue to evolve. Here at the stand, we've been talking through some of our advancements in machine learning and computer vision, and also looking at where we're going next with artificial intelligence, our recent purchase of Blue River Technologies, and really how John Deere is trying to help farmers continue to feed the world.
And you mentioned that there's computer vision at work in this combine. Tell us about that.
So one thing we're really excited about with the new S700 series combine, what you're seeing here, is we have some camera technology that's now embedded into the key aspects of the combine. So what you're seeing here is the grain elevator, right? Think of the combine as a factory on wheels that's going through that cornfield, harvesting, and what's coming out up here is actually the desired product. If we're harvesting corn, for example, there's going to be kernels coming up here, and what's coming out the back of the combine is going to be compost, right? So it's going to be chopped up pieces of stalk, leaves, and all of that.
All the stuff you don't want.
Well, yes, actually farmers actually do want to keep that on the field because then it puts nutrient back into the soil, right? Hey there, Jennifer. What I was talking through earlier is, as that material is coming up, now our equipment is able to allow the operator of the equipment to also program and in essence have the machine make those adjustments for them, which is in essence taking care of what is the farmer's payday, right? So they've been investing quite a bit into that crop cycle, so it's making those adjustments for them on the fly. These days, the average farm for the U.S. farmer is about 5,000 acres, and for these guys, it's a very narrow window of time. So there are times working, 12 to 16 hour days. So both through driving or self-driving equipment, through this computer vision and automation that's in our equipment today, it actually helps them do so more productively.
Right, and with the computer vision in particular, the result is higher yield and less foreign matter in the...
Certainly. So, think of it this way. As we mentioned earlier, as they're going through harvesting, that's the farmer's payday, right? So we're trying to help them maintain the best quality grain that's collected, and also make sure that with those tailings or what's coming out of the back of the combine, they aren't losing any of that grain also.
Awesome, thank you.
Pretty cool, right? Of course, there were also a ton of drones here at CES. While they're getting smarter and smarter each year, one startup is attempting to give drones superhero-like powers.
All right, cool. I'm here with Leah with Asheville AR. What's Asheville AR up to?
Oh man, okay, so we build drones that stop bullets. We've developed a sensor array. We're performing sensor fusion directly on the drone. It's all edge. We are an NVIDIA Inception partner. That's how we're able to do this. That's how we're able to get the type of hardware necessary to run those machine learning algorithms directly on the drone. We're doing all of this edge. Millimeter wave radio frequency combined with computer vision and other sensors I can't really delve into, but I assure you the ability to detect the difference between a fake gun and a real gun, a loaded gun and an unloaded gun. We can read the writing on the backs of the shell casings loaded into the gun.
Wow. So now when I hear a drone that stops bullets, I think of like Wonder Woman bracelets and like getting in front of the bullets in real time. That's not really what this is doing.
Not exactly. Because the drone is able to identify the gun, the presence of a firearm in advance, we identify this as an anomaly, not a firearm. It's just an object of interest for which a police officer is made aware of. We're not trying to take anybody's guns, but you can't shoot people. The drone will take up a position that we refer to as guardian angel mode. It will get ready to get involved. Now, it assesses threat based on the proximity of a hand to a gun. Any hand, any gun. So yes, they are absolutely they're absolutely capable of getting in the way from that vantage point. And also, there is a human reflex that we are exploiting in order to ensure that this works. Do you remember in Terminator, do you remember how Sarah Connor, she's running at the security guy, he knows how dangerous she is, and yet, when she tosses the keys to him, his hands come up. Yeah. That is a human reflex. It is universal. The drones will rush you. They will make themselves the most interesting thing in your world for about the next 30 seconds. They will be extremely difficult to ignore. It's like ignoring a flying blender. If you're familiar with the canine technique of bark and hold, it's a canine. Canines can be trained to rush someone. They'll jump up and down and bark. Bark. Yeah.
We're getting a live pseudo-live demonstration of bark and hold here.
Yeah, of a bark and hold is what that's called when police do it. And it's impossible to ignore that dog. Exactly the same principle. It is impossible to ignore those rotors. Those rotors are, it's loud, it's making noise. We have red and blue. You're absolutely right. Police drones.
So you've got millimeter wave technology that sounds like it can see through walls and objects and determine.
The sensors that we use are actually capable of detecting cancer over the air. We repurposed them for this.
Okay, and
they
so
were
you're
originally designed to perform. It's basically a handheld MRI.
Okay.
Yeah, and so we.
And what's the range?
10 meters.
Okay.
It's about 30 feet. Now these work best in pairs, so about 60 feet.
Okay, and so it detects that there's a gun present and kind of takes a guardian angel position, and it also sounds like you're doing some kind of pose detection to pose detection.
To a certain extent, yes. This it's relevant.
Danger is predicted by proximity of hand to gun. The
Okay.
second that hand touches that gun, active shooter protocol activates. Drone gets within 5 and 10 feet of that person, and the only thing getting shot is the drone.
Yeah. So
Right. Yeah. This is the armor.
Oh, this is one of the armors. This is the raw armor.
Raw
the
armor.
produced armor has a backing of ceramic or Kevlar, or depending on what we use.
Bulletproof acrylic.
Okay.
It's a composite. It is a composite. And I mean, believe it or not, we actually have bulletproof pantyhose. I know, right? I'm not even kidding. I'm not kidding. It works. What can I say?
And so I mentioned
Come on over. What's that?
We're completely
Move out of the way, dude. You're blocking our. Yeah.
I mentioned the trajectory thing, the
Trajectory
pose
tracking,
detection,
yeah,
because
the
you mentioned trajectory tracking.
Yeah, trajectory tracking. It's mostly focused on what is the gun doing in the hand.
So it kind of estimates the departure angle of the bullet from the gun and gets in the way based on that.
I mean, it's also trying to provoke you to aim at it.
Okay.
Yeah, so this is very much so an active process that it is trying to get you to, hey, I'm over here, pay attention to me. For God's sakes, we make the armor shiny.
Okay, and so it sounds like it's pretty inference heavy. You're not kind of sending information to a cloud and waiting for...
Absolutely not. We absolutely, if we tried to send this over the cloud, someone would get killed.
So what are you using on device?
No, like I said, we're an NVIDIA Inception startup. We're also Arrow partners, and we are.
So like a Jetson, or what's the
Xavier?
Okay.
Yeah, we're using Xaviers. I know these
Xavier?
are TX2s. We're not going to bring. We're not going to bring the Xaviers. We're not taking that down off the block. Sorry, guys.
And this is a model of the...
Yeah, that's the raw model. That's an Intel Arrow, the raw model. That's the raw basic drone that we use. As you can see, we also incorporate these. This is a D415 that we've incorporated. We have an excellent relationship with Intel, an excellent relationship with NVIDIA, an excellent relationship with Arrow, and we are producing some custom hardware, some custom silicon in order to achieve these purposes.
So what are the key things you've had to learn from a machine learning and AI perspective or deep learning perspective?
This is a lot easier and a lot more straightforward than people seem to think.
Okay.
Yeah. I mean, quite frankly, this is as much... That and the FBI doesn't like it when I talk about this too much. I mean, I want to deep dive this. I love it. So, I mean, but there's only so much I can say.
Okay,
Yeah.
got it. Well, very cool application. I hope this works out.
Absolutely, absolutely. Oh, there's one last thing I would like to say. No, we do not weaponize the drones, ever, under any circumstances. We will not add pepper spray, we will not add a taser, we will not add anything that will make this into a weapon. It is a shield, that is its job. Yes, you can defeat it with a t-shirt. You go right ahead, that's like messing with a cop's canine. You see what happens.
Yeah.
Now, you wouldn't know it by the name, but CES continues to showcase more and more enterprise-oriented innovations each year. One enterprise robotics vendor, Omron, uses a ping-pong playing robot that's actually not for sale to demonstrate their industrial chops.
How does this work?
So this is Morpheus, our 5th generation AI-equipped table tennis tutor, and essentially it uses machine vision to monitor the player, to watch the player's body language, also how they swing the paddle, and then also where the ball is, and uses AI to compare that to how it was taught from an expert player. So it'll use that and actually try to teach the player to get better. So it uses the vision to analyze, to see where the ball is. It uses the AI to analyze how the player is playing against the other and how to help them improve. And it also uses high-speed control to be able to get the robotics in the right place to be able to actually play and keep the rallies going.
Okay, and how many cameras are involved?
There's 5 cameras.
5?
Yeah.
Where are they located?
So they're actually in the front. So if you look
All in the front?
they're all facing the player, looking
Okay.
down and again, watching the player, watching the paddle, watching the ball.
And this isn't a product you sell. Why do you show this here?
Yeah, even though we do get offers to sell it, it is actually just a demonstration of our technology. We use the same technology in industrial automation, healthcare, in mobility, and also energy management. So this is kind of fun, but those other places are what it does for a living.
Okay, awesome.
So here's an industrial automation application of some of the same technology you see in Morpheus. If you look at the robot behind me, it's doing a pick and place application, which is very typical in a factory automation setting.
Kind of pick and place?
So basically picking up something from one conveyor, one place, and sorting it and putting it somewhere else.
Okay.
So it's a job that is not really good for humans to do because it's repetitive. So it's an example of being able to take an unsafe job and be able to do it with a robot instead.
And it's using the same technologies in terms of computer vision and task planning and the like?
Right, exactly. So if there's vision similar to what's being used in Morpheus, looking at the conveyor line to find and locate the items that are on the conveyor line, and then the same robot that's usually used for the paddle is also being used in the pick and place application here.
If you were a fan of our AI in Sports series last year, you would love CES. There were a bunch of really exciting sports tech applications on display there. One interesting one was this AI-powered boxing trainer, BotBoxer, which can be yours for just $20,000.
This is BotBoxer. It's an intelligent punching bag. It can move, but it can also see your shots. So it tries to it tracks multiple points of your body and tries to predict where the shot is going to come from.
So it's using computer vision to do that?
It uses computer vision, yeah. And with time, it also learns your style.
Okay.
And so it can look at you and it can try and tease you. It can it can see you winding up a shot.
Okay.
And it's gonna predict where the shot is coming from based on that.
And how's it doing that? Is it
We're tracking the upper body.
so kind of upper body angles and using that to predict what shot?
We use multiple track points. We can see you doing this, for instance, telegraphing a shot. It also understands when you're trying to trick it, right? Like good boxers, pro boxers, they strategize. They would come at one angle and then they strike it at another. So BotBoxer can also understand these things, and at different levels, it can try and dodge the shot. But here, you can work on your boxing technique, but it's also an awesome upper body cardio workout machine. We have different modes. We have drills mode. You can work on your different punches. It'll give you standard boxing combinations, jabs, crosses, hooks, and it'll build you a workout routine.
Awesome. Yeah, thank you. One of the product categories I was most excited about at CES was health and fitness technology. Here, we speak with Frank McGillen of Krell, a wearable tasked with delivering chronic pain relief using AI and neurotechnology.
So I'm here with Frank McGillen with Krell. What's Krell doing?
So Krell's the first pain relief solution to integrate neurotechnology plus AI to deliver a personalized approach to treating chronic pain.
All right, so let's break that apart. So
Neurotechnology.
neurotechnology.
Yeah.
What is the neurotechnology aspect of Krell?
So neurotechnology is stimulating sensory nerves with high frequency, high powered electrical stimulation, and it triggers the body's natural pain blocking mechanism.
Okay.
So we launched our first generation product in 2015, and this year we brought AI to make the product even smarter and react better to the patient's needs.
And so how specifically are you using AI?
Yeah, well, we have 70,000 users from our first generation product who volunteered their health profile information. So we're able to look at everything from, where do they have pain, how long have they had pain, other health conditions, body mass, age, all those factors. And we applied machine learning to that data to look at clusters, to find similarities in clusters, and we've built that into a smart algorithm into the Krell device. So when a new user gets Krell, they're benefiting from all the learning we have from those 70,000 people.
Okay, so what's an example of something that machine learning helps you do better?
Yeah, so we found that certain phenotypes of pain sufferers that our normal calibration may misjudge what their dosage should be.
Okay.
May say that their dose should be lower or higher, for example, than what they really need.
And by dosage, we're talking about the amount of electrical stimulation.
Exactly. So, and the key to getting quality relief is getting the dosage right. If you think about if you're taking a pain medication, if you're taking 10 milligrams and you need 100, you're not going to see relief.
Right.
Well, the same thing with neurostimulation or electrical therapy. So, based on our smart algorithm, we're now actually factoring in hundreds of variables in addition to this nerve sensitivity test we do when you first use the product.
Okay, awesome. And do you have it looks like a band that you wear. You don't happen to have one on you, do you?
I actually do. So, it's worn under your leg here.
Okay.
And it's controlled through the app. So we have a Krell app here which lets you, helps you manage the device. We provide a lot of tracking information. So we're not only collecting some of this profile data, but we're also collecting things like activity, gait, sleep. So we provide a lot of tracking information, and again, we're using this data not only to make the device smarter, but also helping prove in the real world how to achieve drug-free pain relief.
Okay, and are there other examples of where machine learning or AI have come into play beyond the calibration?
So that's our first step.
Okay.
We're really, again, trying to make sure we benefit from all the data we've collected from our current users. What we're looking at for next step is how to apply that not only in that initial calibration, but on an ongoing basis.
Okay. Awesome. Thanks so much, Frank.
Cool. Thank you.
Perhaps my least favorite category at CES was so-called smart cities. Not because they're not smart, but rather because too often it's just a thinly veiled euphemism for the surveillance state. That said, my conversation with Mantis was interesting because they claim to fix something that we all hate: traffic.
All right, cool. So I'm here with Alexandros from Mantis. What is Mantis up to?
Mantis, we are predicting what will happen in your traffic route before you get there. So we can give you, for instance, information about an upcoming traffic jam 30 minutes or 1 hour or 2 hours into the future. And the beauty of it is you can avoid it if you know it's going to happen. Now, in order to do this, you need some advanced mathematics, and this is where Mantis come in. We have a patented algorithm already that combines machine learning and stochastic modeling in order to produce this advanced forecasting of your future route to work or home. So you can actually get there in time before anyone else. But of course, it's not just for just private users. The municipalities gain because there is reduction in fuel, there is reduction in congestion, there is reduction in pollutants for the environment. So everybody gains by avoiding a congestion, for instance.
So the idea is that you're combining statistical models with more model-based approaches.
Exactly. So machine learning is, as you know, useful to predict patterns in the usual historic information. So machine learning finds out what is usually going to happen in traffic. But to figure out what will happen in the future, the patterns is not always very accurate because traffic is chaotic phenomenon. Mm-hmm. So to figure out what happens in the future, we use our own stochastic algorithms, which is like predicting what will happen in the stock market, together with the machine learning. And those two combined together allow us to have amazing accuracy for future events before they occur.
Okay, and so these are like your kind of jamming machine learning models
Pretty
and like Markov processes,
is
MM1Qs and MMNQs
Fantastic.
and all
You're
that kind of stuff?
So it is Markov modeling together with Monte Carlo for the simulations. Exactly right.
Okay, so primarily simulation based.
Yes, absolutely.
Okay.
Because once you simulate based on the real data what will happen, then you can start avoiding the problems.
Okay.
Because you know where they will occur. In that location of the road, in 30 minutes, I'll have a traffic jam. I know what to do now.
Okay. And you've got some of the use cases here, and you're also displaying some of the results you've seen.
This is an example in Sweden. We got real data in blue versus green, our predictions, which is right on top of each other.
Yeah.
And this is over several days we can do that.
Okay.
An amazing thing, which is really important, is this graph in the bottom. So down here, you have the usual traffic jam, but then on the 23rd of November, there is no traffic congestion. Yet we predicted that there won't be any. You know what happened on the 23rd of November?
Looks like Black Friday.
It's a Black Friday.
Okay.
And you know why this is amazing? If you go around, any machine learning algorithm will predict the pattern. Every, 5 o'clock you have a traffic jam, but they won't predict it's a Black Friday. We predicted it was a Black Friday. No traffic jam.
Seems like it would depend on what kind of features you're using. Like if you're feature engineering kind of tags historical data with events like Black Friday, it would do a better job at predicting it.
So
what allowed your approach to do it better?
The stochastic patented algorithm is what allows that, because it's not only looking at the patterns which reoccur, but says what will happen in the future based on the current information. And then the stochastic algorithm takes over for the future and never ever hit the congestion because it was a Black Friday. I don't know how it happened because I don't control the stochastics, right? It's a Markov process.
Yeah.
It's a random thing. It will do its own thing, but it figured it out on its own. That's why we saw this. It was an amazing result.
Huh. And so the data sources that you've played around with are primarily traffic-based, or are there others?
So we use whatever is provided. In this case, we have cameras and video, so we use that, but we can use RFID, tube detectors, you name it. Whatever we are provided, we use it. It can all go in as input in the algorithm. It doesn't care.
And what was the origin of the technology?
The origin is my own because I'm a mathematician.
Okay.
So I actually created my own stochastic model because I work in traffic.
Okay.
To simulate traffic. And because it's a chaotic phenomenon, it was research for me, but I saw the obvious advantage here, so I created a company.
Okay. And so have you published on this at all?
Oh, yes.
Or?
After we did the patent, then we published it.
Okay. And where can we find that? What's the name of the paper that folks should look at?
There are several papers now.
Okay.
I've been giving different conferences the information so I've published a number of papers by now.
Any particular one we can start out with?
Asymmetric simple exclusion processes.
Asymmetric simple exclusion processes.
For traffic dynamics, yes.
Okay, awesome.
Yep.
Alexandros, thank you so much.
Autonomous vehicles come in all different shapes, sizes, and form factors at CES, and one of the most impactful applications targets people with limited mobility. Check out this clip for a look at a computer vision equipped wheelchair developed by Hubox Robotics, a startup partnering with Intel.
You can see all my facial expressions and all the data I can capture, all the points.
Gaming situations, low latency, really great for computers. And then in the back here we have conference drives. So lots of stuff we see.
So this is what is running inside the Intel NUC. So in real time you can capture facial expressions in a more precise way than any other technology can do. So which allow us to use the keys to stop the wheelchair, open mouth to go to one side, and just turn it off. Right. And a kiss to stop, raise that eyebrow, kiss to stop, open mouth, and kiss to stop. And a quick smile, and move forward. And even a tongue out, sometimes I can go backward. So you see the precision, you see the quality of the capturing facial expressions technology. So this is what we are delivering to the market using the RealSense camera and also the Intel NUC. Is our onboard computer that I have here underneath the wheelchair. So we are processing everything locally to capture those facial expressions. So far we can capture 10 facial expressions. You can use 5 of them to control your wheelchair, and the other ones you can talk to Alexa by Amazon, for example.
So from a AI perspective, is this based on a supervised type of model? Did you train it on?
It's already pre-trained.
Okay.
So what we did was we create a huge data set of 3D faces because we are using 3D technology. We pre-trained it to classify 10 facial expressions. I'll give you an example. We are able to classify like a full smile, a half smile, and a shy smile, for example. So this is huge, right? And using 3D technology, we are able to do this regardless of the light condition. So what we did was we create 2 layers. This is 2 tech, right? But we create 2 layers. One, using machine learning, so we can classify those facial expressions. And the second layer, we use some heuristics. So I have never met before, but if you're smiling right now, I can tell that you are smiling, right? So we just teach the algorithm to detect this. So we have 2 layers, one machine learning, and now we have a heuristics one. So we start to optimize this technology using the Intel distribution of OpenVINO. So now we can OpenVINO.
Okay.
So now we can have a deep learning layer. So 3 layers: machine learning, heuristics, and also deep learning. And we can do this all online, all offline, just using the NUC here underneath the wheelchair.
Another application in a corporate setting.
So here I can perform some facial expressions.
Just
turn on.
Outsiders, it can alert whoever needs to know that I'm not necessarily there. Same thing like a backpack is left on the ground.
A quick smile to move forward.
There, it's probably a threat, and then they can handle it accordingly. So that's kind of what
Raise that eyebrow. Open mouth.
AI, underneath here, we have a partnership with Vacant.
And even a tongue out,
I
I can move backward.
So they're taking,
Cool. Thank you.
All right, everyone, that's our show for today. Be sure to like this video and smash that subscribe button down below. For more information on any of the awesome companies or technologies you saw today, visit TWiMLAI.com/talk/222. As always, thanks so much for watching, and catch you next time.